Welcome to The Explainer. Today, we're tackling a fascinating scientific riddle, one that's hidden all around us, right in plain sight. It's a subtle little difference in words that actually reveals a huge amount about how our physical world really works.
Okay, so let's just dive right in with our central puzzle for today. Every surface is an interface, but not every interface is a surface. Now I know, that sounds a bit like a brain teaser, right? But trust me, by the end of this, it's gonna make perfect sense. Let's break it down.
So to get to the bottom of this, we've got to start with the basics. We have to understand the building blocks. First up, what exactly is a surface, at least in scientific terms?
Okay, so here's the deal. The key thing you have to remember is that a scientific surface isn't just any old boundary. It's very specific. It's the line where a liquid or a solid meets a gas. And yeah, that gas is usually just the air around us. And you see this all the time. Think about a simple glass of water. That perfectly flat top layer, that's the surface. And why? Because it's the exact point where the liquid water meets a gas, the air above it. Pretty straightforward, right?
Okay, so we've got surfaces down. Let's move on to the second part of our puzzle. What then is an interface?
Now, an interface, well, that's a much broader term. It's the boundary between any two different phases that just don't mix. The scientific word for that is immiscible. So this could be two liquids, a liquid and a solid, you name it. As long as they stay separate, the line between them is an interface.
And the classic example here, the one everyone thinks of, is oil and water. You know that shimmering, distinct line where they meet but just refuse to mix? Yeah, that is a perfect example of an interface.
All right, so now we have both pieces of the puzzle, right? We know what a surface is, and we know what an interface is. So let's put them together and finally crack this riddle.
Let's bring it all back to that initial statement. Based on what we've just learned, what's the crucial difference here that makes this riddle true?
And the answer, it really lies right here when you put them side by side. A surface is super specific. It has to involve a gas. But an interface, that's way more general. It can be the boundary between any two things that won't mix.
So what does this all mean? It means a surface is just one very specific type of interface.
A really good way to think about it is like this. All squares are rectangles, right? But not all rectangles are squares. It's the same idea. A surface is a special kind of interface. And if we look back at our examples, this just clicks into place. The water meeting the air, that's a surface. And because it's a boundary, it's also an interface. But the oil meeting the water, that's only an interface. Why? Because there's no gas involved. See the difference?
So, look, if you take away one thing from this, let it be this. All surfaces involve a gas. That's it. A surface is just the special name we give to an interface that happens to have a gas on one side. If you can remember that, you've totally cracked the code.
And that really leaves us with a final thought, a challenge for you, actually. The world is just full of these boundaries, so just look around you right now. Your desk, maybe your coffee mug, even the screen you're looking at. How many different